Hi everyone, my name is Adam Lax and my partner is Nikhil. Our project will be predicting future success of Major League Baseball players. As lifelong fans of baseball, we have both been curious as to what makes a player successful. Predicting the success of a baseball player is extremely important as player contracts can exceed hundreds of millions of dollars. Because of this, a model that can accurately predict success could save a team from a bad investment. We decided to measure success by WAR, as it measures a player's value in all facets of the game by deciphering how many more wins he's worth than the average replacement level player at the same position. WAR stands for wins above replacement.
So there's been a little bit of work looking into this in the past by a couple papers we analyzed, but they haven't done exactly the same thing as us. So the first paper we looked at predicted WAR of players in their seventh year after 6 years of data. Now this means you have a less flexible input space. You can't really predict players that are in their first or second year, and you can't do predictions for any given next year. It has to be their seventh year. So we found that that wasn't exactly what we were looking for. And the second paper we looked at predicted OPS, which is a different stat on base plus slugging. Again, it trained individual models for every player. So it wasn't great for players that were newer, didn't have a lot of data. It was good for predicting players that already had 6, 7, 8 years and were predicting their following year. But because it was player by player, it didn't capture league-wide trends. And we also felt that WAR was a more comprehensive metric than OPS. So that's why we chose it for our project.
All right, so to answer our initial question, we studied a data set provided by ESPN. This data set is available from 2002 to 2018 and contains 18 numerical variables for over 150 offensive players per season. This data also includes a summary statistic WAR. In order to make sense of our data, we first coded a correlation matrix and removed variables that are correlated with each other. This process suggested that the most relevant variables for predicting future WAR are runs, batting average, doubles, walks, OPS, or on base percentage plus slugging, and WAR. Following that, we separated our data set into a training set and a testing set and scaled our data. After prepping our data, we decided to utilize three models to determine the most appropriate way to predict future WAR. First, we applied a linear regression model. The goal of a linear regression model is to find the line of best fit by calculating the optimal values of intercepts and coefficients such that the error is minimized. Similarly, we also utilize polynomial regression in the hopes of determining the values for intercepts and coefficients that do not share a linear relationship with the target value variable future WAR. Finally, we included k-nearest neighbors regressions. K-NN regression attempts to determine patterns in data and returns the average value of the k closest neighbors for each value being tested.
So we evaluated our models using three different metrics: mean squared error, mean average error, or mean absolute error, and R squared. And we did this using two different data sets. First, we use all the features, and then we use just the selected features that Adam just talked about. For our full data set, we found that the linear regression and KNN regression performed roughly equally, but the polynomial regression performed a lot worse. For a selected data set, linear regression strictly performed better than KNN, and polynomial regression was still third. And this makes sense because we picked our features in our selected data set based on their linear correlation. So we expect that they have a better linear relationship compared to the other models. Between now and when we finish the project, we want to incorporate a few more things. We want to incorporate pitching statistics and possibly also fielding statistics, because currently we only use hitting statistics. So if we can get a more comprehensive measure of players' performance, we can maybe get a better prediction of WAR. We also want to use one-hot encoding for categorical variables, specifically position, because a player's position can affect which statistics are more important. We also want to use k-fold cross-validation as a better way to evaluate our model rather than simply a train test split. We want to perform hyperparameter tuning to get the optimal hyperparameters for our models. Currently, we just guessed and we picked a good number. For example, for our KNN, we picked k equals 15. And for our polynomial regression, we capped at degree equals 2. But if we use grid search and other methods to find good hyperparameters, we can possibly improve the performance of our model.